The answer is that electrical and plumbing threads are different. Section 344.28 of the National Electrical Code states that conduit threads shall be tapered threads. According to the NEC, conduit threads shall be tapered threads with a taper of 3/4 inch per foot, that is 6.25 mm over 300 mm. The length of the thread shall not be less than the length of the coupling. This same taper is used in plumbing, but the pitch of the thread is different. Electrical threads have 11.5 threads per inch, while plumbing threads have 14 threads per inch. This means that you cannot use the same dies to thread electrical and plumbing pipe. Therefore, the statement that you were told at your code update course is incorrect. You cannot use plumbing dies to thread electrical conduit. To elaborate on the differences between electrical and plumbing threads, let's delve into the specifics of each type. Firstly, the taper is a critical aspect. Both electrical conduit and plumbing pipes utilize a 3/4 inch per foot taper, also expressed as 6.25 mm per 300 mm. This taper is essential for creating a tight, leak-proof seal when the threaded connections are made. The taper ensures that as the joint is tightened, the threads bind together more firmly, providing mechanical strength and preventing loosening due to vibration or pressure changes. Secondly, the thread pitch is where the divergence between electrical and plumbing threads becomes significant. Thread pitch refers to the number of threads per inch along the length of the pipe. Electrical threads, specifically those used for rigid metal conduit and intermediate metal conduit, adhere to a standard of 11.5 threads per inch. This specification is crucial for maintaining consistency and compatibility within electrical systems. Plumbing threads, on the other hand, typically feature 14 threads per inch. This difference in thread pitch might seem minor, but it has profound implications for the interchangeability of fittings and the integrity of connections. Thirdly, the implications of using the wrong thread type are severe. Attempting to join an electrical conduit with a plumbing fitting or vice versa will likely result in a connection that is not only mechanically unsound but also potentially hazardous. The mismatched thread pitches prevent the threads from fully engaging, leading to a weakened joint that is prone to leakage or separation under stress. In electrical systems, a compromised connection can lead to arcing, overheating, and even electrical fires. In plumbing systems, a faulty connection can result in leaks, water damage, and potential mold growth. Fourthly, the National Electrical Code, or NEC, plays a vital role in regulating the installation of electrical systems, including the specifications for conduit threads. Section 344.28 of the NEC explicitly mandates that conduit threads shall be tapered threads with a taper of 3/4 inch per foot. This requirement is in place to ensure that electrical connections are made safely and reliably, minimizing the risk of electrical hazards. Plumbers, on the other hand, follow a different set of codes and standards that govern the installation of plumbing systems. These codes specify the appropriate thread types for plumbing pipes and fittings, typically calling for threads with 14 threads per inch. Fifthly, the use of appropriate threading tools is essential for creating accurate and compliant threads. When working with electrical conduit, it is imperative to use dies that are specifically designed for electrical threads, featuring 11.5 threads per inch and a 3/4 inch per foot taper. These dies will ensure that the threads are properly formed and will mate correctly with electrical fittings. Similarly, when working with plumbing pipes, it is necessary to use dies that are designed for plumbing threads, featuring 14 threads per inch and the same 3/4 inch per foot taper. Sixthly, the materials used for electrical conduit and plumbing pipes can also differ, which further reinforces the need for distinct threading practices. Electrical conduit is typically made of steel or aluminum, while plumbing pipes can be made of materials such as steel, copper, or plastic. The choice of material can affect the threading process, as different materials may require different cutting speeds and lubricants to achieve optimal results. Seventhly, in addition to the thread pitch and taper, there are other subtle differences in the geometry of electrical and plumbing threads that can impact their interchangeability. For example, the thread form, which refers to the shape of the thread profile, can vary between electrical and plumbing threads. These variations, while seemingly minor, can affect the way the threads engage and seal, further emphasizing the need for using the correct thread type for each application. Eighthly, it is important to note that the information provided in the original code question, which stated that threaded plumbing pipe also requires a 3/4 inch taper per foot, is accurate. However, the conclusion that the same dies could be used for all same size piping needs is incorrect due to the difference in thread pitch. The taper is the same, but the thread pitch is different, making the dies incompatible. Ninthly, the statement from NECA 101-2001 Standard for Installing Steel Conduits, Section 4.11, which says although coupling threads are straight-tapped, conduit threads are tapered. Use the standard 3/4 inch per foot taper national pipe thread die is partially correct. Conduit threads are indeed tapered, and a 3/4 inch per foot taper national pipe thread die is used. However, it is crucial to use a die with the correct thread pitch for electrical conduit, which is 11.5 threads per inch. Tenthly, the use of mismatched threads can have legal and insurance implications. If an electrical system is installed with plumbing fittings, it may not meet the requirements of the National Electrical Code, which could result in fines or other penalties. Furthermore, if a fire or other incident occurs due to a faulty electrical connection, the insurance company may deny coverage if the installation was not performed in accordance with the applicable codes and standards. 11thly, it is always best to consult with a qualified electrician or plumbing professional if you have any questions or concerns about thread types or installation practices. These professionals have the knowledge and experience to ensure that your electrical and plumbing systems are installed safely and in accordance with all applicable codes and standards. 12thly, understanding the nuances between different types of threads is not only crucial for professionals but also for homeowners undertaking DIY projects. Even seemingly simple tasks like replacing a faucet or adding an electrical outlet require a basic understanding of thread types to ensure proper connections and prevent potential hazards. 13thly, it's worth noting that while the focus here is on the differences between electrical and plumbing threads, there are also different types of threads within each category. For example, there are different types of plumbing threads used for different applications, such as tapered threads for pipes and straight threads for fittings. Similarly, there are different types of electrical threads used for different types of conduit and enclosures. 14thly, the use of thread sealant or pipe dope is often recommended when making threaded connections, regardless of whether they are electrical or plumbing. Thread sealant helps to fill any small gaps between the threads, creating a tighter seal and preventing leaks. However, it is important to use a thread sealant that is compatible with the materials being joined and that is approved for the intended application. 15thly, when inspecting threaded connections, it is important to look for signs of damage or wear, such as stripped threads, cracks, or corrosion. Damaged threads can compromise the integrity of the connection and should be replaced immediately. Corrosion can also weaken the threads and make them more prone to failure. 16thly, in some cases, it may be necessary to use thread adapters to connect pipes or fittings with different thread types or sizes. Thread adapters are available in a variety of configurations and can be used to bridge the gap between incompatible threads. However, it is important to choose thread adapters that are specifically designed for the intended application and that are made of compatible materials. 17thly, the cost of using the wrong thread type can far outweigh the cost of using the correct thread type. A faulty connection can lead to costly repairs, water damage, electrical hazards, and potential legal liabilities. Therefore, it is always best to err on the side of caution and ensure that you are using the correct thread type for each application. 18thly, the evolution of thread standards has been a long and complex process, with different standards emerging in different countries and industries. The National Pipe Thread Standard, or NPT, which is commonly used in North America, is just one of many thread standards used around the world. Other common thread standards include BSP, ISO, and metric threads. 19thly, the use of thread gauges is essential for verifying the accuracy of threads, especially when working with critical applications or when using unfamiliar threading tools. Thread gauges are precision instruments that can be used to measure the pitch, diameter, and taper of threads, ensuring that they meet the required specifications. 20thly, The information provided here is intended for educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or plumbing professional before undertaking any electrical or plumbing work. To summarize, the key differences between electrical and plumbing threads lie in their thread pitch, with electrical threads having 11.5 threads per inch and plumbing threads typically having 14 threads per inch. While both types of threads utilize a 3/4 inch per foot taper, this difference in pitch makes them incompatible. Using the wrong thread type can lead to unsafe connections, potential hazards, and code violations. Always use the correct dies and fittings for each application and consult with a qualified professional if you have any questions or concerns. By understanding these differences, you can ensure the safety and reliability of your electrical and plumbing system. Now to expand on National Pipe Thread, or NPT, let's discuss the characteristics. Firstly, it is a U.S. national standard for tapered threads used on pipes and fittings. Secondly, it is designed to provide a leak-tight seal for fluid and gas transfer. Thirdly, the taper rate for NPT threads is 3/4 of an inch per foot. Fourthly, NPT threads are commonly used in plumbing, heating, ventilation, and air conditioning or HVAC, and other industrial applications. Fifthly, NPT threads are available in various sizes ranging from 1/8 of an inch to 12 inches or larger. Sixthly, NPT threads are designated by their nominal pipe size, such as 1/2 inch NPT or 3/4 inch NPT. Seventhly, NPT threads are typically made of steel, brass, or plastic. Eighthly, NPT threads require the use of a thread sealant such as Teflon tape or pipe dope to ensure a leak-tight seal. Ninthly, NPT threads are not interchangeable with other thread types such as British Standard Pipe or BSB threads. Tenthly, NPT threads can be either male or female. 11thly, male NPT threads are tapered in the outside diameter of the pipe or fitting. 12thly, female NPT threads are tapered on the inside diameter of the fitting. 13thly, NPT threads are tightened using a wrench or other tool. 14thly, NPT threads should be tightened to the proper torque to avoid damaging the threads or the fitting. 15thly, NPT threads should be inspected regularly for signs of wear or damage. 16thly, NPT threads should be replaced if they are worn or damaged. 17thly, NPT threads are a reliable and widely used method for connecting pipes and fittings. 18thly, proper installation and maintenance of NPT threads are essential for ensuring a leak-tight seal and safe operation. 19thly, NPT threads are subject to various industry standards and regulations. 20thly, NPT threads are an important component of many industrial and commercial systems. Another thing to discuss is the different types of conduit. Firstly, rigid metal conduit, or RMC, is a heavy-duty, thick-walled tubing often made of galvanized steel, suitable for outdoor and harsh environments, providing excellent protection against impact and corrosion. Secondly, intermediate metal conduit, or IMC, is lighter and thinner than RMC, but still made of galvanized steel, offering a good balance of protection and cost-effectiveness for various applications. Thirdly, electrical metallic tubing, or EMT, which is thin-walled, often made of galvanized steel or aluminum, easy to bend and cut, suitable for indoor use and concealed locations, not ideal for harsh environments. Fourthly, flexible metal conduit, or FMC, is a spiral wound, flexible steel or aluminum conduit, useful for connecting equipment that vibrates or moves, and for navigating tight spaces. Fifthly, liquid-tight flexible metal conduit, or LFMC, is similar to FMC but with a waterproof plastic coating, suitable for wet or damp locations and outdoor use where flexibility is needed. Sixthly, rigid PVC conduit, or PVC, is a lightweight, non-metallic conduit made of polyvinyl chloride, resistant to corrosion, suitable for underground and direct burial applications, and often used in corrosive environments. Each type of conduit has its specific applications and advantages, and the choice depends on the environment, protection requirements, and budget.